Okay, so we started out looking at a finished piece that's kind of complicated. There's a lot to this. And we went through it and we talked about rendering the circle and so forth. So let's back up a little bit, simplify things. This is oscillator.txt. This comes with the examples in the txt folder. And these two lines, this is the simplest LaserBoy liquid math script that you could write that actually puts something on the screen so that you can see it. So let's see what it is. Okay. It's a sine wave, right? Actually, let's make this a little easier to, there, a little easier to see. Okay. All right, so let's make this a little bit easier to see what's going on here too, okay? Grab this stuff right here, this bit, and I'm gonna put it right here. Whoops. Right here. Okay. Now, remember I said all of these parameters, they already exist before you even open a text file, okay? And they all have default values, and these are the default values of these particular parameters. And you'll notice all of these are attributes, I guess, parameters of a LaserBoy oscillator called 1. Okay, so this is LBO1, and these are parameters that are associated with this oscillator. So let's turn this on so we can see what we're dealing with as far as the unit reference is concerned. And we'll go ahead and see these are all here, but like I said, they're all default values, so putting them here has no effect because we're not changing anything. But go ahead and save this, and we'll open it, and it looks like there's the unit circle, there's the sine wave. Put the two together, and you end up with this. See, this is a radius of 1. This is the origin of space. This is also 1, positive 1, negative 1 with respect to the origin. And the distance between here and here is 2 pi, which is 1 whole cycle around the circle. All right, so back to here again. As a matter of fact, let's take a look at that first of all. Let's just change duration. Now remember, I said duration. Well, start and duration are in units of 2 pi, which is something else that you can change. That's another parameter. You could make it in. You could make it in radians. You could make it in degrees. You can make it whatever you want. But by default, it is in cycles of 2 pi, which is full rotations around the unit circle. So if we make it 2 here, and we save that, and we render it, you get 2 cycles, right? Right there. So there's the first cycle, and there's the second cycle. So from here to here is 2 pi, 4 pi. Okay? And all we did there was just change duration. In other words, how far are we going to go on the real number line, plugging numbers into the into this LaserBoy oscillator here, so that when we call the generator that uses this thing, it's calculating over the interval from 0 to 4 pi, right? Okay, let's put this back to 1 like it was. Now let's look at some of these other parameters. Amplitude. Let's make this 3. Alright, we'll save that, and we'll render it. Oh. Losing my mind. there's the origin. There's there we go. There's the origin. There's 1, 2, 3. The amplitude is 3. -1, -2, -3. This is still the same interval from 0 to 2 pi. Okay? Okay, so that's amplitude. Right? Another thing that we can change here is frequency. Let's make this 10. Oops. 10. Okay. Now, by default, iterations is 100, which means, back to here again, you can see there are, well, hang on. Okay. See, there's 100 vertices. In this image. And if you want to see just the vertices, the only points that are actually being calculated here are those. This is t, right? From 0 to 2 pi, this is t, and this is LBO1 of t is the y-axis. So those are the iterations. So in order to make this a little easier to see, if we do some more complicated, we'll just go ahead and we'll make this value 1500. So now there'll be 1500 iterations, right? And okay, like I said, we've already got the amplitude at 3, and we just changed frequency to 10. Save that. Go back to here and here. Okay, and 4. There's the unit reference, and there's 10 cycles with an amplitude of 3, right? Right? There's the origin. This is still the interval from 0 to 2 pi, but now the frequency is 10 and the amplitude is 3. All right? Another thing we can do, these are all attributes of the LaserBoy oscillator, or parameters of the LaserBoy oscillator. See this offset here, okay? Let's make this 4. Yeah, okay. Save that. Here. And 4. Hey, see the origin is down here now? That's because this is an offset of 4. From here to here, if you just look at the sine wave all by itself, this is the 0 value of the sine wave, right? And if we just added 4 to it, that's the offset. So it's 1, 2, 3, 4. So that's gives you an idea of what the various attributes are. I'll show you another one that's kind of neat. It's different. Code here, and damping factor. I'll leave that'll work. Set it to 1. It's positive now. That means it has a damping factor. Damping factor is a numeric way to indicate how much energy is lost in the swing of a pendulum over time. And it is an exponential thing because over equal periods of time, a swinging pendulum loses an equal amount of energy. So half and half and half and half and half is an exponential loss of momentum. All right. So, and that's what the damping factor is here. It's basically part of how you simulate the swing of a pendulum. Okay, so let's look at it. All right, and let's go. In 4 oscillator. See, it loses energy, right? it starts off, and it's as soon as the very next point from this one right here, which is the first vertex, the very next one is starting to lose energy until it decays down to almost nothing. Okay, so that's damping factor. All right, whoops. All right, back to here. Okay. Now let's put these back to the default values, right? So we've got frequency of 1, or excuse me, amplitude 1, frequency 1, phase 0, duty cycles 50%, damping factor 0, offset 0, okay? And we're back to our default settings, and we already know that is 1 cycle of a sine wave if it is rendered over the interval of start at 0, duration of 1. Okay, and we're doing it in 1500 iterations. Alright, so now let's talk about animation, how animation is notated in LaserBoy Liquid Math, because that's really a big part of what the language, why I developed it, was to be able to do animations. So the way we do that is going back to here. Let's grab this chunk right here and put this right here. Alright, now you notice it's still an LBO1, but it's got an underscore in front of it, which makes it different. This is our initial state values for the first frame of an animation, and this is our final state values for the last frame of an animation. And by default, the setting for frames is 3, so you get the first one, the middle one, and the last one. But we want to see more than that, so make it 50. By the way, the alignment of these things is absolutely irrelevant as long as there's at least one space between here and here. So it doesn't matter. I just like my stuff to be readable. Alright? So, we set frames to 50. As I said, the default is 3. So if you want anything more than that, you got to set it. Also, this 1500 is iterations. Now, here's something that's interesting. Because we're doing an animation and we're talking about an initial state and a final state for the first frame and the last frame through a set of however many frames you want, these are also attributes of a single state of a frame. So these also, let's do this. Keep things organized a little bit. It doesn't really matter what order you do these things in, and let us accept that they do need to be done before you use it, right? So this has to be above this in order to affect this, okay? All right, so here we're gonna, okay, so now start duration and iterations with no underscore, with the LBO attributes with no underscore. That's the first frame in a set of 50, and underscore start, underscore duration, underscore iterations, and all the underscore LBO1 attributes are the parameters that go into generating the last frame of the 50. So in order to see anything happen here, we have to change something. Something has to be different between the two, and we already have that. See, we've already got, see this by default, this is 1, so let's just make it 10 so that you can see there is going to be a change. Frequency of 1, frequency of 10. First frame, last frame in 50 frames. So here, instead of just regular oscillator generator, we're going to use the underscore oscillator generator. The underscore in front of a generator name indicates this generates an animation, a set of frames, not just a single frame. And it is, obviously it relates to all of these things that the initial frame, and then the final frame. All these beginning with the underscore. All right. So let's render this thing and see what it looks like. And remember, we returned the default values of LBO1 back to, we've returned it to default, so it's just one cycle of a sine wave. Alright, there's the origin of space, and there's the first frame, which is a sine wave. There's the last frame, which is 10 cycles of a sine wave, and there's the frames in between. And we made this animation thing. Okay? By the way, this doesn't have to be here, obviously. So it's just this is what we made. Okay. So that's the foundation. That's the beginning idea of how animation is done. Initial state parameters, final state parameters, number of frames you want, call a generator that makes an animation. Those begin with the underscore character. Okay? And we can animate more than one of these parameters. We can animate any of them that we want to. Like we could make the offset go to 5, for example. See here, the offset is 0. Here the offset is 5. So there's a change. And also, we still have the frequency of starting at 1 and ending at 10. Also a change. So save that, and we'll render it. And there's our unit reference. Let's just get rid of that, and we end up with, look at that. It's increasing in frequency and it's offset. It's moving up.